In the quest for a sustainable energy source, scientists are reaching for the stars. Fusion energy powers our sun and all the stars in the night sky. The immense force of gravity at the sun's core forces hydrogen nuclei together so tightly that they fuse, releasing vast amounts of energy. But recreating these conditions here on Earth is a huge challenge, and so unlocking the secrets of fusion requires far more than just ingenuity. Supercomputers lie at the heart of fusion research, enabling scientists and engineers to rapidly simulate and analyze prototype fusion power plants, optimizing their design and efficiency. If fusion can be harnessed economically here on Earth, it will provide a near-limitless source of safe and reliable low-carbon electricity.
So Dawn, the UK's fastest AI supercomputer, was made in partnership with Dell and Intel, using a brand new processor from Intel called the Intel Data Center Max GPU. And these technologies are really aimed specifically at AI and simulation, and that's really quite new for the UK to have such a large GPU system that combines both AI and simulation capability in a single platform. So being based here at the University of Cambridge, we obviously work with some of the brightest minds in the world, really focused on some of our grand research challenges today. We're focusing, Dawn, on the development of green fusion energy, climate change, and health informatics. And really those three broad areas are some of the initial focus points of Dawn.
So Dawn is an incredibly exciting project to catalyse what is necessary to design fusion power plants in silico, that means in the virtual world. There's no time to do test-based design anymore. We've got to encode everything that we know into models and workflows that will run on these very powerful supercomputers. The fusion power plant is a very strongly coupled, very complex piece of machinery. It has to be to contain the conditions of a star down here on Earth. There are a number of big challenges that we're facing. The most notorious of which is plasma turbulence, trying to simulate the plasma itself and understand the plasma and tame it to be able to get power out at the scale that we need. Then there's the magnetic bottle itself, the device that we use to contain this 100 million degree plasma. The strongly coupled nature of all of the physics means that really, to meet the very demanding timeline that we're facing to deliver these power plants for the net zero era, we've got to be able to digitally twin the entire system, the strongly coupled system.
In general, a digital twin is where we make a digital mock-up of a real-world scenario. That will involve simulations, vast amounts of data and AI, so that we can make a digital representation of a real physical scenario. In this case, working with UK AEA, we're making a digital model of a green fusion energy plant so that that design process can be greatly enhanced and accelerated, so we can get that clean green fusion energy on the grid much faster if we can make digital models instead of having to make physical models.
The key thing about climate change is that there's a very rapidly ticking clock where we need to deliver solutions at speed. I've spent my whole career really working on the problem side of climate change, and that's where the focus on climate modelling is. But I'm particularly excited about work that's now being conducted on the solutions side, and a really important component of that is around fusion and the development of prototype fusion plants. Supercomputers like Dawn are really central to the development of that, and that's why I'm so excited about the opportunities.
STEP, the acronym, stands for Spherical Tokamak for Energy Production. It's a prototype power plant that we're going to stand up in the early 2040s to demonstrate that the concept is commercially viable.
Supercomputers like Dawn are essential to be able to deliver fusion and the fusion strategy. The overall goals of the UK fusion strategy are to lead the world in commercialising fusion energy. That is, taking our fusion systems, our technology, our supply chain and the adjacent industries and converting that to deliver a commercial, clean energy system through fusion. AI and AI computing will be an important part of being able to handle those millions of data points and being able to understand the patterns of plasma and plasma science and plasma chemistry needed to develop the commercial reactors of the future.
So systems like Dawn will really transform the UK's research agenda, making those global challenges, those global research problems much more practical, bringing in the time to solution in healthcare, in climate and green energy, so that we can live healthier, we can have more green energy solutions and hopefully understand our climate much faster than we can without these technologies.